In this lesson, we're going to examine three-dimensional trigonometry. So we're going to be applying our SOHCAHTOA rules, our sine law, our cosine law, but in diagrams that involve three-dimensional applications. So we'll start with a nice visual. We have a cuboid here. Fancy name for a rectangular prism. We want to find the length of AE. So AE is the line that goes through the bottom from corner to corner. Now the fact this is a cuboid allows us to redraw this triangle that we just formed. A is here, E is here, B down here. And we know B has to be right angle if it's a rectangular prism, a cuboid. We've got 12, we've got 10. We want to find this. Well, we don't need any fancy math to do this. We can use Pythagoras. A squared plus B squared equals C squared. And if we punch into our calculator, we'll get 244 is x squared. The square root of 244 comes out to approximately 15.6 centimeters to 3 sig figs. In part 2, we want to find BG. Again, kind of handy. We can redraw this. The fact that this is a cuboid is when I take the slice this time, down the middle here, we've got F in the corner. It's got to be right angled. We've got G, and we got B. Now, F to G is the same as E to H, so we know this is 4.5. And the diagonal that goes from A to E has to be the same as the diagonal that goes from B to F. So we can use our part 1 answer to do our part 2 question. And again, we're doing Pythagoras. So we now have 4.5 squared plus 15.6 squared comes up to x squared here. Into our calculator we go, square root it, and you should get 16.3 centimeters. Okay. Part B, we want to find the angle between A, E, and B. So that goes back to our first diagram. A, E, and B, it's always the middle letter that tells us which angle to find. So we want angle E. Now, the fact that this is right angled allows us to use SOHCAHTOA. And because we actually know all three sides of this triangle now, we could use sine, cos, or tan. I'm going to use tan. So the tan of E, the middle angle, would be my opposite, 12 over 10. I'm going to take the inverse of that, 12 over 10, into my calculator, and I ended up with 50.19 ... or in other words, 50.2 degrees. Now, that's one option. As I said, you have SOHCAHTOA, you have all three sides. You could use the cosine law. You could use the sine law if you really want to. You got to pick and choose which one you want to use. In part C, the angle between the plane ABEF, that's the bottom of our thing, and the line A to H. So A to H is the one that goes from corner to corner. Basically, the same angle that's being formed here is the same one that was formed over here. Okay. The angle at B. So I actually have all the information I need. I just take my picture from picture B. If I want to find that angle, again, I can use SOHCAHTOA, I can use sine law. I'm going to use tan again. This time it's the tan of B. I know it's 4.5, 15.6. I'm trying to find this angle right here, right? Use my inverse tan again, and if you do that, you should get 16.1 degrees. Okay, the trick in this question is recognizing the information you have and trying to draw the picture that will help you solve for that piece of information. Again, there's other ways of approaching this. You could have used sine law, cosine law, different types of SOHCAHTOA. You got to pick and choose which one you want to use, which makes sense in your brain. But take a look at your diagram and see what information you've gathered. Okay, the next set. It's all examples today, okay? For point B, Manny uses the clinometer, which just measures angles, to determine the angle of elevation at the top of a cliff is 38. From point D, 68.5 meters away from Manny, Joe estimates the angle between the base of the cliff, himself and Manny to be 42. So he's gone from the cliff to himself and then to Manny. And we always say it's the angle in the middle that matters, right? That's where the 42 came from. Manny does the same thing. He gets his angle of 63. We want to know how tall the cliff is, letter H. Now we can do this because these two triangles that are formed share something. They share the side BC. One of the triangles is flat on the ground. That's the C, D, and B triangle. And the other one, ABC, is a vertical triangle. But because they have that shared side, we can take information from one and use it in the second. It's kind of the advantage of having multiple triangles, is they often have things you can share. So if I want to find side Y, I know it matches up with the angle of 42. That hints to me I want to use either the sine law or the cosine law. I can find the third angle of my triangle, the angle right here, by taking 180, subtracting 42 and 63, that's 105, leaving us 75 degrees. Well, 75 is across from 68.5. That's a sine law question. If I match those two up, and I match up the 42 with the side that I want, that I'm going to use later on, I can call it y. I can cross multiply this. Y sine 75 equals 68.5 times the sine of 42. I want to solve this for y. So 68.5 times sine 42 over the sine of 75. Put that all into my calculator, and I got 47.45. There's more decimals than that. I'll just keep them in my calculator. Now that I know that, I can find the height of my cliff by using the right angle triangle. In particular, I now know the opposite. Sorry, I want the opposite, and I know the adjacent. So I can use tan. The tan of 38 equals my opposite, the height of the cliff, over the adjacent 47.45, whatever that comes out to. We'll cross multiply. We'll plug that into our calculator, and I already have the exact answer for the previous thing in my calculator, so just times it by tan 38, and I end up with the cliff being 37.1 meters tall to 3 sig figs. Again, the important thing was this shared side, and recognizing that if I can find that, I can use that to help me further in this question. Okay, let's switch it up. I'm going to try something a little bit more challenging now. Drawing a 3D question. The first two gave us the 3D. We just had to visualize what was happening, the parts and pieces. Now we're going to have to draw one. So we got Emma. She's on a 50-meter high bridge and sees two boats anchored below. From her position, boat A has a bearing of 230 and boat B has a bearing of 120. She estimates the angles of depression to be 38 for boat A and 35 for boat B. How far apart are the boats to the nearest meter? Now, to do this question, we need to think of it in two ways. We need to think of an aerial view, an overhead view. So if we put Emma right in the middle, the boats are on a compass from her. One of them is at a bearing of 230, so 0, 90, 180, 270. 230 would be about here. From 0, that's that far. The other one's on a bearing of 120. I'm going to move my number there, sorry. It's in the way. 230. 120, which would be about here. That bearing is 120. That's B. That's A. We want to know how far apart the boats are. So from an aerial view, they are, put a dot here, that far apart. Well, the angle in the middle I can figure out pretty easily. It's the difference between my two bearings. One was 120, one was 230, so the angle between them is 110. And this would be a totally normal bearings question if I were to know this side and this side. We'd have two sides, the angle between them, figure out how far apart the boats are. But right now I don't know how far it is from Emma to either boat. So here's where the 3D part comes in. Emma is standing on top of a bridge. The bridge is 50 meters high. Okay, so if we think of this bottom as being the water, we've got one boat over here, and we've got another boat over here in the water, and they are X apart. We know the angle between them is 110 degrees. We also know when Emma's standing on top of the bridge looking down at the boats, the angle of depression, so from her position way up here on top, down to the boats, creates angles of depression. In other words, these side triangles are actually right angled And our angle of depression, which is from the horizontal down, is 38, or to get it in the diagram, 38 and 35. And if I can figure out y and z, I can figure out how far apart the boats are. But I need to think of those side triangles. I'll just draw one here just so we can all agree on what that looks like. 38, y, bridge, 50 meters high, boat, A. Then I can solve for y and z and use those two to get x. So how am I going to solve for y and z? I'm going to have to use tan. So the tan of 38 equals 50 over y. I'm using this little side triangle right here, this one. I need to solve for y. I'm going to cross multiply this. Y tan 38 equals 50. So y is 50 over tan 38. And I know that boat A is 63.997 meters from Emma. I can do the exact same thing for the other triangle. The only difference is it's an angle of 35. And we're going to call it Z this time. So the same cross multiplying and dividing. So Z will be 50 over tan 35. And that one, that boat, is 71.41 meters from Emma. Well, if I know those two things combined, I can use my cosine law and go back to this flat triangle, the one that's on the water itself, to find x. And so we'll get x squared equals 63.997 squared plus 71.41 squared, b times c times the angle between them, which we said is 110 degrees. And put that all into our calculator. We get approximately 12,330.6007. Square root it, and they are approximately 111 meters apart. But the key there again is recognizing they have shared sides. The three-dimensional picture has a flat surface and a vertical surface that share that side. In our case, sides y and sides z. Trying to draw that picture can be awfully challenging sometimes. Okay, last one. I'm going to combine some English in here for you. Suppose Romeo is serenading Juliet when she's on her balcony. Romeo is facing north and seeing the balcony at an angle of elevation of 20. Paris, Juliet's other suitor, is observing the situation is facing west. Paris sees the balcony at an angle of 18. Romeo and Paris 100 meters apart is shown. Figure out the height of Juliet's balcony. So again, it's a similar kind of question. It's three-dimensional. We got a flat triangle. We got vertical triangles. These vertical triangles are going to be at right angles to Juliet's balcony, but also because one's facing north and one's facing west, the angle on here is a right angle also. That's kind of a key for us. This question is a slightly more challenging one because they're giving us the opposite information this time. They're asking us to find the height of the balcony and telling us how far apart the two things are. So to approach this one, we'll try it in the same way. If I can find these shared sides, x and y, I can use them to figure out h. So where do we start? What do we know? We know that the tan of 20, using that left side triangle, would be h over x. But I got two variables there. I can't really do much with that. So what else do I know? I know the tan of 18 equals h over y, the right-hand triangle. Again, I got two variables. But the nice thing is, if I have two variables and two equations, I should be able to solve something, right? But if you actually look, we now have three variables. So we need something else. If you think about the flat triangle for a second, I hope you would agree that x squared plus y squared equals 100 squared. It's a Pythagorean relationship. So if I rearrange these equations for x and y, I can plug them into this equation. Here's how we can do that. That's cross multiply, and then x will be h over tan 20. If we do the same thing for the other one, y tan 18 equals h, or in other words, y is h over tan 18. I could then take my Pythagorean relationship and say, okay, x squared, in other words, h over tan 20 squared plus y squared, h over tan 18 squared should come out to 100 squared. Well, now when you have one variable, one equation, I can solve this. Right? I actually have to figure out what this number happens to be. Now, inside the bracket, it's really 1 divided by tan 20. So if we type it into our calculator, 1 divided by tan 20, we get 2.747. Okay, so what I'm going to do here is I'm going to think of this as 1 over tan 20 with an h attached to it. I'm typing in the 1 over tan 20 into my calculator. I get approximately 2.747 h. We want to square that. We're going to do the same thing for the next one. 1 divided by tan 18 is approximately 3.078 h squared, and 100 squared is 10,000. Okay, now we have decimals. Decimals are a little bit easier to work with. Makes our life slightly easier. So when we square them, we end up with 7.5486 h squared plus 9.472 h squared equals 10,000. Well, I can collect like terms. It's just algebra now, right? We got 17.0207 h squared equals 10,000. So h squared, if we divide 10,000 by 17, we get approximately 587.519. And if I square root that, I get 24.2 meters. That's how tall her balcony is. But to do that question, I had to recognize the information that I was given. In particular, this is a tricky one, the fact that I had a Pythagorean relationship there, and I could solve for h using some things that I knew about x and y. As I said, that's a tricky one. You won't come across too many that are that difficult, okay? Most of ours will be like the previous question, where we need an aerial view and a side view and figure out what we're sharing. Okay, some questions you should try, just a couple of them. There are some you have to draw. Some of them are given to you, but some you have to draw. I just want to point out that the answer in the back of the book for 3D is wrong. They've done some math that's actually not possible. And the answer should be 64.2. But if you're stuck, come see me. We're going to move on to a different kind of trigonometry starting tomorrow. So we're done with our sort of our SOHCAHTOA sine law stuff. We're going to move on to new stuff. So it's kind of our last chance.